Hello guys, my name is Novi Darmayani.
And my name is Dina Anggini.
Today we are going to presenting our project for a requirement of our final exam on Artificial Intelligence courses. The title of our project is Controlling a Fan DC based on Fuzzy Logic.
First, I'm going to explain what is the project about. This project is about how to control an ideal DC fan speed from the result of monitoring gas sensor and temperature sensors. This project used two sensors, the LM35 temperature sensor and the MK2 gas sensor, and the output is to control the DC fan speed. When the conditions are hot and there is smoke, the fan will spin fast or on. If the conditions are cold and there is no smoke, the fan will spin slowly or off, and so on depending on the phase zero.
Next, the goal of this project is to be able to apply temperature sensors and gas sensors as an input of fan control using microcontroller-based fuzzy logic methods.
And the scope of this project is limited to things like MK2 sensor that is set only to detect smoke and LM35 sensor that are used to detect temperatures, which can control the DC fan's rotation speed.
Next, timeline. On our first and second weeks, we made the program using Arduino software. On our third and fourth weeks, we made the hardware using the sensors, Arduino, the fan DC, and power supply. And also we've tested the program to the hardware. On our fourth and fifth weeks, we took the data.
Our project run when the sensor detects there is change in temperature rising or hot and there is smoke, and the fan speed will be fast. But when the temperature is low or cold and there is no smoke, the fan will stop rotating. Now we're going to take data from the project.
First, the input is in low condition for the temperature sensors, and also the gas is in low conditions. So the output is 0. Now, if I put to the 5-volt, the temperature sensors detect the temperatures of the room, so the fan is rotating. Now we are going to check the temperature sensor is rising and now is going to be 100. Now the gas sensor. The gas sensor is also rising. It's about 200 now. And stop. And we are going to take one of this data and we are going to calculate it. Next, I want to describe how the project relates to fuzzy logic. First, what is the part of fuzzification? Fuzzification is a process to convert sensor variables into linguistic variables using membership functions stored in fuzzy based. Second one, what is the part of inference? Fuzzy inference is a process of formulating mapping inputs to output using fuzzy logic. The process of fuzzy inference involves the membership function of the fuzzy logic operators and if-then rules. There are three best-known inference methods: Mamdani inference method, Takagi-Sukeno inference method, and the last one is Tsukamoto inference method. Tsukamoto inference is an extension of monotone reasoning. In the Tsukamoto methods, every consequence of a rule in the form of if-then must be represented by a fuzzy set with a monotone membership function.
Next, what is the part of the fuzzification? The fuzzification is a process used to convert fuzzy variable back into real variables, or in the other word, fuzzy control action that still state. Converted into real value in the form of a single value. As a result, the output of the inference result of each rule is given explicitly, or CRIPS, based on the strength predicate or Fire strength, the result obtained using a weighted average.
Dependencies. Now I want to tell you how to make the project from the software to the hardware. First, prepare all the tools and materials needed. Second, make a membership function from each inputs and outputs. Third, make a rule base to calculate final result for the speed of fan DC. Fourth, and then create a program based on the fuzzy. Programs are made from the inputs, membership function, rule-based, and the fuzzification. This is our program. This is the initialization of the gas sensors and the temperature sensors, and also the rule. This is the fuzzification and the membership of our sensors. The first one is gas sensors, and the second one is temperature sensors. Now we are going to see the rule base. Here is the rule base. We use the Tsukamoto method, and this is the fuzzification. From here till here. Fifth, place the MK2 on the protoboard, where on MK2 there are 3 pinout. Output pin is connected to pin A1 on Arduino. VCC pin are connected to pin 5V on Arduino. Ground pin are connected to ground pin on Arduino. 6. Place LM35 on the protoboard, where on LM35 there are 3 pinout. Output pin is connected to pin A0 on Arduino. VCC pin are connected to pin 5V on Arduino, and ground pin are connected to ground pin on Arduino. 7. Place MOSFET IRF 540 on the protoboard, where on MOSFET there are 3 pinout. Drain pin is connected to wire negative from fan DC. Gate pin are connected to pin PWM3 on Arduino. Source pin are connected to ground pin on Arduino and the wire negative from power supply. 8. Connect the wire from fan DC to a positive wire from power supply. 9. The last step is upload the program to Arduino and run it. This is our program. Now we are going to upload the program to the Arduino. Now we're at a room and the temperature is about 29 to 30 degrees Celsius, and the gas is detect about 128 to 130 plus part per million, and this is the result.
Conclusion. The fan can be controlled based on the temperature and gas condition around the sensor by using fuzzy logic. Fuzzy itself serves to regulate fan speed so that when the temperature rises or is hot and there is smoke, the fan speed will be fast. When the temperature is low or cold and there is no smoke, the fan will stop rotating. With the control system, the fan will be more effective in its use.
And the last page this is the references that we use. Thank you for watching.